This session is continuous testing with Molecule, Ansible, and GitHub Actions. And how many times have you had something happen when you're on a project and throughout the project, it might be a project that you started on fresh and it was a new thing, or you might have come into the project after it was in maintenance. And every sprint or every cycle of development, you end up spending a lot of time fixing bugs and trying to get in those new features that marketing or sales wants you to put into the product. But it seems like you spend more and more time progressively on bug fixes and hot fixes and things like that. A lot of projects get into that rut. And a lot of times the reason for that is you don't have a way to detect and identify problems in your project early on and before they become an emergency. And when you have an emergency, you have to drop all your other work and start working on that emergency. And so you slow down your feature progress, you slow down your maintenance work, and it becomes a very vicious cycle. And I'm somebody who has been on many of those projects before, and I've learned from them that one of the best ways to prevent that cycle that burns people out and that makes projects be a terrible thing to be on is to make sure that you have systems in place that find problems before they hit production, before they can become something that causes everybody to drop their work on it. And so I found this quote when I was doing a little bit of digging for this presentation, and I thought it really sums it up well. The earlier that you catch defects, the cheaper that those things are to fix. And it's really something that I think sums up why you would want to test a system continuously and why things like continuous integration systems are so important, especially for modern infrastructure. In the past decade or so, infrastructure has gone from being something that you kind of put together and you have it running and you don't really touch it too much and somebody kind of knows how a system works, but it's not actively developed. Nowadays, infrastructure is part of the core of our services that we run. And it's so important that one little infrastructure problem can cause outages and cause revenue to be missing, things like that. So it's more important than ever to be able to have the assurance that when you make changes to a system, and a lot of people are making changes now on a monthly or a weekly or a daily basis, those changes aren't going to break anything. So who am I, though? The I on this line is a little bit off. Sorry about that. But who am I and why am I qualified to talk about this? My name is Jeff Geerling. I'm known more often as Geerling Guy online. And if you use Ansible or if you've used Ansible for a while, you might have seen some of my work on Ansible Galaxy. You might use some of my roles. But I also have written a book on Ansible called Ansible for DevOps. And it's a case study in how important continuous integration and testing can be and how much better it makes the support of a product. In this case, the product is a book. I wrote this book, I started writing it in 2013, and I published the first full version of it in 2015. Since then, I've made 24 major additions and changes to it, and now it's in its second edition. Throughout all that time, all of the examples that I wrote for the book, I put them into a GitHub repository. And throughout that time, I've tested every day. It runs the full book's test suite. And anytime that there's a new feature in Ansible that might cause a problem or have a change that requires some changes in my code, I always keep those things up to date. And maintaining this book and making it relevant for everybody who buys it, no matter when you bought it in 2015, when Ansible 1.8 or 1.9 was out, or if you bought it yesterday when Ansible 2.10 is being released, no matter when you buy this book, it's going to be relevant because I can keep the examples updated. I can keep it updated with the times. And some of these examples are very real world examples that you might be maintaining in your own infrastructure. So that's one case study that has shown me the continued importance of having good continuous testing. I'm working on another book called Ansible for Kubernetes. And my original goal with that book was to finish it by 2017. You know how many years it's been since then. So I'm still working on that book, but I have also done the same thing with it, where all the examples that I'm writing in the book, I have in a GitHub repository, and it's running tests every day to make sure that those examples still work. And in the world of Kubernetes, things go even faster. So it's been so helpful to see the day that something changes that requires me to update my infrastructure, I'm able to see that and fix the book before this change even affects people who are reading the book. I also maintain tons of projects on GitHub and elsewhere. I have over 200 projects on GitHub, 200 open source projects. And those projects among them have 27,000 stars and 14,000 forks, which means they're used by a lot of people. They're forked by a lot of people. And I really like the fork stat because I tell people all the time, with open source, especially with small open source libraries, sometimes what I do to make them maintainable is I will not accept a lot of features that makes things more complicated and makes them harder to test. Because the more things that you add in your product, the more things you should be testing if you want to have a maintainable, stable product. So a lot of times with my libraries, I like to keep them small and lightweight, but I encourage people to fork them and make changes specific to their use case and maintain their forks of them. And so a lot of people do that. But all of these different things that I maintain, I would be able to do none of this without continuous integration and testing. And I've used so many different platforms and products over the years, from Jenkins to Travis CI to Circle, Drone. Now I'm using GitHub Actions a lot, and that's why I am going to talk about GitHub Actions, because it's very similar to a lot of these other tools. But the cool thing about it is it's built into GitHub, and a lot of people who use GitHub would be interested in integrating it. I'm also going to talk about using Molecule, which is a great infrastructure testing and even development tool that is maintained for the Ansible community. And it integrates very well with GitHub Actions. So the example that I'm going to talk about in today's presentation is found in chapter 13 of my book, though you don't need to get the book to follow along. And this whole example, all the code for it, and even some more detail is in the book's repository, which is open source. So you can go and download it if you'd like. There will be a link to that at the end of this presentation. But if you are interested in the book, you can get it at ansiblefordevops.com. So I have a playbook here. This is a pretty simple playbook. It's going to install Apache. And I actually have a few playbooks for production infrastructure that look very similar to this. They have a little bit more detail, and there might be some more files that are managed. But on the whole, if you want to set up a static Linux web server, really this is all that's needed. You might want to add some security things and some user account management. But this playbook is about as simple as it gets for something that you might see in the real world. And if you notice that I'm using the service name and the package name HTTPD, so this playbook is meant to be used on Red Hat or Fedora or CentOS systems. If you tried running this on Ubuntu or Debian or some other system, it wouldn't work on, because it uses the package name and the service name Apache too. So you could make this playbook flexible, and Molecule and GitHub Actions both actually can work in ways that are flexible with multiple OSs. But in this case, I'm just targeting Red Hat or CentOS. So I'm going to build the playbook specific to that. And this playbook's really simple. It just has a handler, because when you copy a file and you make changes to it for your website, you want to make sure that the web server is restarted, just in case there was something like a CGI script or something that would need to update and be updated in the caches. So I have that handler, and there's a task to make sure that Apache is installed. There's a task that copies the web page into place, and this web page is really simple. It just says hello world, but this could be anything. It could be copying a website directory. You could be cloning a Git repository into a document root for Apache. And then the last thing it does is make sure that Apache is running at boot up. So this playbook targets let's say it's just a AWS instance or a DigitalOcean droplet or something like that, or just a VM running anywhere, or even a bare metal machine. But it's really simple. And the main reason I wanted a simple playbook is because this presentation is not about how to use Ansible to do major deployments or anything. This is about how to use Ansible to test any playbook that you might have, any Ansible automation that you might have. As long as Ansible can run the playbook, you can use Molecule to test it. So the next step here is we want to be able to use Molecule to test this playbook. And so setting up Molecule is pretty simple. I typically install Ansible with pip, so I like to install Molecule with pip when I'm doing my development work on my own workstation. So installing Molecule is simply pip3 install Molecule, and then I have in square brackets there Docker. I typically use the Docker driver for Molecule. That means Molecule will bring up a Docker container to run the tests inside of it. you can use different drivers. There's drivers for Amazon, there's drivers for Podman, there's drivers for all kinds of different things. And I just, since I do a lot of work in Docker, I just use the Docker driver, and that's typically the default that people will use anyways. After you have Molecule installed, you need to create a Molecule scenario, and a scenario just describes to Molecule what is the environment like that I need to deploy into. So in my case, I want to deploy into a CentOS environment or a Red Hat environment, or I could use the universal base image. But whatever that environment is, you need to tell Molecule how to set it up. And by default, it will give you, I think, a Red Hat style environment. But I'm going to be a little more specific and tell it what version of CentOS to use and which Docker image to use, all that kind of stuff. So after you create that scenario, you need to modify it a little bit. So I ran Molecule in its scenario, and it creates a directory called Molecule in my playbook directory. And the playbook's name could be like main.yaml or playbook.yaml or apache.yaml, whatever you want it to be. So I run Molecule in its scenario, and then it creates a folder called Molecule, and then the default scenario is called default. So there's a folder called default in there. And that scenario will create a few files. The most important file to tell Molecule about your test environment is the molecule.yaml file. This describes all the different parts of your testing and development environment that you want to use in Molecule, and all the steps that you want to run to make sure that your Ansible playbook is running the right way. Another thing that I usually do, you can see in this molecule.yaml file, there's a lint section on lines 6 to 9. In that lint section, you don't have to do this, but again, I like to make sure that all my playbooks are always working and will always follow the best practices in Ansible, and also are properly formatted YAML. Some people have a lot of trouble with tabs versus spaces and line endings and all those kind of things. So if you run these linters on your playbook all the time, they'll pick up problems like that before you try running it in production and it fails for some reason because there's an extra space somewhere that you didn't want it to be. So I run these commands YAML-int and Ansible-int, and if you want to run YAML-int and Ansible-int, you need to also install them with pip. So pip3 install YAML-int and pip3 install Ansible-int. They'll be available and you can run them. A couple other important sections. The most important thing here, I changed the platforms from the defaults that Molecule gives you. The one thing that I like to do is test services inside my containers. And if you want to run a service that runs inside of a container, you need a init system, because Docker and Podman are typically meant to run one executable. Like when you run the container, it runs that one thing. And if you want to run Apache and run it with like service start or systemd, then you need to have the container set up to run systemd when it boots instead of running your one Apache process. So I'm testing this in Docker, even though the target of this playbook is a general Linux server. So what I did was I told it I want to use a special Docker image that I maintain called docker-CentOS 8-Ansible. And that Docker image actually has systemd installed on it and ready to go. But you have to do a couple more changes to be able to do this. And this is how I do almost all my roles, because I usually target Linux VMs. And the VMs obviously have an init system running on them. So I also I set the command to an empty string. That way, the command from my Docker image that sets up systemd will run. I also set up a volume to the C group so that the Docker container has the ability to use that. And then I turn on privileged. I set privileged true, and that lets Docker let this image run in an init system. If you don't do that, then it won't work correctly. Now, this is something where you need to trust whatever Docker images you're running, and you need to also trust the software you're installing on it. If you didn't trust Apache, you probably shouldn't be using Apache. If you don't trust me, then, well, maybe I'll have to do something else to earn your trust. But you could also maintain your own Docker image that you trust to be able to use in your test environments. If you want to set it up this way and use privileged access so that it can run services through systemd. Anyway, everything else in there is pretty standard, the driver dependency and all that kind of stuff. Our playbook doesn't use Ansible Galaxy. It doesn't use any rolls off of Galaxy. But if you did and you just had a requirements.yaml file, Molecule would automatically pick that up and run the installation of all those Galaxy dependencies before it runs your playbook. So the other thing that you need to change to tell Molecule what to do is Molecule was originally built for Ansible role testing and development, but Molecule can be used for anything Ansible. So in our case, we just want to run this playbook that we created, that Apache playbook that we created earlier. And like I said, I saved it as main.yaml. You could call it whatever you want. But all that we need to do to tell Molecule to run that playbook instead of a role or something is to put into the converge.yaml file. And this is what Molecule runs when it does testing, when it does converge, when it does other commands that set up an environment for you to test in. All you have to do is put import playbook and then the path to the playbook. So in this case, we're in the default scenario, which is molecule/default. So we need to go up 2 directories back to the playbook directory. So // main.yaml. And now we've told Molecule that we want to run that main.yaml playbook when it runs its test cycle or when we build an environment. And the last thing that we want to do is also use Molecule and use Ansible to verify that our test environment is running the way it should be. So at the end of that playbook, I want to make sure that I can load a web page. I want to call localhost and see if localhost is responding with a 200 OK response. Make sure that Apache is running correctly. If Apache installation failed, but it didn't fail in Ansible somehow, or if the startup worked, but it's not actually serving the right directory, then this would fail. So I have a playbook in verify.yaml, and again, that's just alongside converge.yaml and molecule.yaml. This verify playbook, all it does is one task. In the real world, with a lot of my playbooks, I might have 5 or 6 different things that verify that a configuration file has the right value, or it might verify that the response has the right headers, or things like that. But basically, make sure that your application is running the right way, or your website is responding with the right content. In this case, I'm just testing that Apache is returning a 200 OK, because it's simple and easy to talk about in a presentation like this. So anyway, I have one task in it, and it's using the URI module to call the URL localhost. And when Molecule runs this, it's going to run it inside of the environment that it sets up. So localhost would be inside of whatever this fresh container that's running CentOS 8 is. And when it calls localhost, it should be getting a response from Apache of 200 OK. So once we have all that, we can run this playbook, and that's what I'm going to do now in the screen recording. And so you can run Molecule test, and when you do that, it will kick off a cycle where it first creates the environment that you're going to test in. It makes sure that that environment has all the required dependencies, and then it's going to run the Converge playbook. You can see it's doing that right now, and run through and do all the things, make sure that Apache is installed, make sure that the web page is in place, restart Apache, and once that's all done, it'll run the Verify playbook on top of it to make sure that the environment is all working correctly. And another cool thing that Molecule does, which it's doing right now, is making sure that idempotence, or the ability to run it once or many times, is successful. So it's going to run it again and make sure that no changes are made. Because when you build Ansible playbooks, you want them to be idempotent, where you run them once and they make the changes, you run it again, and no extra changes are made. That way your infrastructure is not very fragile, where you're changing it all the time and potentially breaking things. Once it's all finished, it will delete the test environment. And if it exits with a status code of 0, then you know that everything worked correctly. Now, one thing that's really cool about Molecule when you're developing playbooks is you can run Molecule Converge, and that will do everything up to the Converge playbook, run the Converge playbook, and then stop. And so I use that a lot of times when I'm developing a playbook to be able to test it. You can do some things, check it out, and then it stops, and then you can log into the environment using Molecule Login and see what's going on if there's a failure, or you can check out some files to see where you need to put a new file. Another cool thing that you can do is use Ansible's debug modules like debug and assert and things like that, or the fail module to just stop a playbook somewhere. And then you can run Molecule Converge and get to that point and dump out some variables to the screen and see things like that. So that is running Molecule locally. Now, the thing that gets really powerful is when you can use Molecule in continuous integration, and that's where GitHub Actions comes in. And like I said earlier in the presentation, I've used so many different CI platforms. It doesn't really matter what you use, but this presentation is talking about how GitHub Actions can integrate, and it's great for anyone that's using GitHub because it's all built in. You can start using it right away. And to do that, GitHub Actions is enabled by default on all new repositories, and unless you disabled it, you should just be able to do these steps and get GitHub Actions running. The first thing that you need to do is create a workflows directory. So in your repository that's on GitHub, wherever the project is, all you have to do is create a file in the path .github/workflows. And then that directory can have one or more continuous integration workflows. And those workflows can do all kinds of different things. Usually what I just do is create a ci.yaml file. You can call it whatever you want. You can call it integration.yaml or testing.yaml. I call mine ci.yaml. And this workflow, I set it up to run with certain conditions, and then you tell GitHub what to do when it runs. And this is the file that I created for this particular project. This is about as bare bones as you'll get for an Ansible molecule testing project. And there's a few special things about it. The first thing is I call it CI because I call the ci.yaml. So you set a name for it, and that name is what will appear in the user interface on GitHub. And then you tell it conditions when to run. So in that on section, you can see there's pull request and then on pushes to the master branch. You can define a lot of different conditions up here, and you can also schedule it. And for most of my real projects, I actually schedule them to run either daily, weekly, or monthly, depending on how important the project is to my income and ability to work. The most important projects get run daily. Other ones usually get run weekly just because I want to make sure they're still working, but they're not going to affect my life if something breaks in a given day. But you can put any conditions in here and schedules and things. This is typically pull requests and pushes to the main branch in your repository are the two things that you'd want to target out of the box. And then you define a list of jobs, and the syntax starts looking a little bit like Ansible. I wonder if the GitHub Actions team, GitHub Actions is relatively new in the world, and maybe that team used Ansible or saw some of the benefits of the way that Ansible works with steps instead of tasks, that kind of thing. But just like with Ansible, I like to document my steps, what they're doing. So the first step is checking out the code base. Second step is set up Python 3. But the only job that I'm defining here is a test job. And again, you can call this whatever. You can call it integration or CI or whatever. I called it test. And then the human readable name for it is molecule. So in the interface, you'll see a CI workflow, and under it, there will be a job named molecule. And I set it to run on Ubuntu latest. GitHub Actions has a few different platforms that it runs on, either Ubuntu, and you can specify a version, or just use latest. You can run it on Windows, or you can run it on Mac OS. I'm just using Ubuntu because I'm targeting Linux, and all the Docker setup that I want to do is easy there. So the first step is to check out the code to the code base, or check out the code into the workspace that you're running in. And that's pretty simple. That almost every project I've ever done does that as the first step. Second step is using an action on GitHub called setup Python. And it's funny, the action is setup Python at v2, but that's the action version. That's not the Python version. The Python version is set in that second part of that, the with Python version 3.x. And then I use pip, which is installed when Python is installed. I use pip3 install, and then I install molecule with the Docker plugin. And molecule is automatically going to install Ansible for me, so I don't have to install Ansible separately. And then I install YAML-lint and Ansible-lint because I'm going to use molecule to lint my code as well when it runs molecule test. And then the last step is the most important here. It's going to run molecule test in GitHub Actions. So just like I did locally, it's going to run it in GitHub Actions. And this is really where the power comes in, because it's going to lint the code. So anytime someone submits a pull request to this project, anytime someone pushes new code to it, it's going to run all these tests, and it'll fail if somebody has a YAML error or something that fails linting with Ansible lint. And it'll also fail if the actual playbook run fails. So molecule test is going to do all that. There's two funny things here in the env or environment section. And these are two environment variables that will be passed in when it runs molecule test. And the first one is PyColors. That's to tell molecule to output color data in its output, even though we're not in a TTY environment. We're not in an interactive shell like we are when we're local. And also Ansible Force Color is going to do the same thing, but for Ansible. The reason I do those is because when you get the output from GitHub Actions or any CI tool, it's all black and white, so it's kind of hard to see when there's an error, when there's changed, or when things are okay and it's green. You don't see those colors without these two variables. So I always add those to my CI environment runs. And so here's a demonstration of what happens when I commit this file to the repository on GitHub. And so after I commit the file, GitHub Actions will automatically pick up the fact that I now have a GitHub Actions workflow. And you can see in the left sidebar, there's the CI workflow, and under it, there's a molecule job. If you click on the molecule job, you can see all the different steps that it's running. So it checked out the code base, set up Python 3. It's installing all the dependencies. After it does that, it'll run the molecule tests. If everything passes, in the end, you get a nice green check mark, and you know that things are working. At least everything that you've tested that works is working. There's always the ability to add more tests to your project. Sometimes you might have too many tests, or some projects might have really flaky tests that break a lot, and that's not a great thing. And I could probably do a whole nother presentation some other time on that kind of thing. But a cool thing that you can also do in GitHub Actions, and this is the same with a lot of different tools, is you can go up to the workflow and get a badge, a status badge for it. And so when the workflow is passing, the status badge is green. When it's failing, it's red. And you can post that badge anywhere. You can put it in the README for your project. You can put it on a status dashboard page for your project, or wherever you want, just to let people see quickly at a glance, like, is my project passing or failing this test right now? Anyway, so that is how we do GitHub Actions workflows with Molecule. And again, like I said earlier, the complete example for this, and it has a little more detail, and it actually uses multiple platforms. So it runs it on Debian and CentOS. Because with a lot of my roles and a lot of my infrastructure, I need to make sure that they work on different platforms, because sometimes I deploy to Red Hat in certain environments, and sometimes I deploy to Debian or Ubuntu or something in other environments. So that's important to me. So I show how to do that as well in this complete example, which is in the Ansible for DevOps GitHub repository, which is on the screen there. And I really want to conclude with the final statement that I think is the most true for me, especially since I maintain so many different open source projects. Here's a little haiku for you. It's impossible to maintain many projects without good CI. And when I actually floated this haiku to other people, someone mentioned it's impossible to maintain any projects without good CI. It's possible. I've just seen so many horror stories that I don't think it's possible in a way that prevents your burnout, and you really want to have projects that people want to work on and want to make better. And the way to do that with infrastructure, modern infrastructure management using Ansible, is to have a good CI process set up. So I'd like to thank you for watching this presentation. If you want to ever get in touch with me, obviously you can ask me questions here, but you can also find me at Geerling Guy on Twitter and on pretty much anywhere, or go to my personal website, jeffgeerling.com, and my email is there as well. So thank you for watching, and I hope you're having a great Ansible Fest.